Yan. Okay, sige. Here we go. Hello. Welcome ulit sa... Eto na. Last lesson na natin to. Sa buong program natin. Kasi, chem na to no? Last lesson na to. Ayun nga, unless na gusto niya pa, no? Pero, here we go. Last lesson na natin to. This is about acids and bases ulit. Teka lang, ha? Good job for making it this far, no? Sipag nyo. Okay. So, hello. Ayun, welcome ulit. So, pagpapatuloy na natin yung discussion natin last time of acids and bases. So, today, we're going to focus on titration, no? Titration is a process na important to quantify yung pH ng ating mga unknown substances, no? Yun ang isa sa mga important na pang-quantify. Or rather, hindi naman pH, rather determine the concentration of an unknown substance, no? Pero before that, meron pa tayong hindi na-discuss about equilibria last time, no? I hope naalala nyo pa kasi today, it's almost puro acid-base equilibria tayo. Kasi pagpapatuloy nga lang, di ba? So, salts, no? Salts. Let's start with salts in equilibrium, no? Nalimutan ko to discuss last time. Pero, salts, what are salts? No? Ionic compounds produced from an acid and base reaction. Diba? Ito yung mga example. Dapat na-discuss nyo to last year. So, here. Yan sila. Salts have are crystallized, diba? Crystalline sila. Mas depende sa mga elements na pinagsasama natin, iba-iba yung properties nila, iba-iba yung kulay nila, and so on and so forth. Then, these salts undergo a process called hydrolysis, no? Ions produced by the dissociation of a salt with water to produce either hydroxide or hydronium ions, thus impacting pH. So, kapag nakipag-interact ang salt sa tubig, magka-hydrolyze yung mga ions niya to produce either hydroxide or hydronium, which can affect the pH. So, let's examine salt solutions, no? So, tatandaan natin, cations of strong bases and anions of strong acids do not react with water after their dissociation. What does this mean? Sige, abangan lang natin. Okay, tignan natin, ha? So basic salt solutions, no? A salt consisting of the anion of a weak acid and the cation of a strong base yields a basic solution. So, basic yun, no? Pero kasi, mapapansin nyo, yung matitirang anion of weak acid, Ka yung binibigay for this, di ba? Ang gagawin nyo, look for the necessary Kb value by using Kw over Kb, over Ka, no? Acidic salt solutions naman, cation of a weak base and the anion of a strong acid yields an acidic solution. So, pansin nyo, wala yung strong acid dito anywhere, no? Kasi hindi na nga siya nag-react sa tubig. So, the necessary Ka value is calculated using the value of the Kb of the weak base, to. Teka lang, ha? Pagawin ko na. There. It's neutral. A salt consisting of the cation of a strong base and the anion of a strong acid yields a neutral solution. No, ions react with water. What does this mean? Ito, example. Para di kayo maguluhan, o diba? Ano to? Li tsaka I. Diba yung Hi, baguhin ko, wait. Diba yung Hi is a strong acid, diba? Ang LiOH ay isang strong base din. So it means na itong dalawa na to is cation and anion of their strong and weak acid. Ay strong acid and base counterparts. So this will be neutral. Neutral siya. Okay? Oh, next. NH4NO3. NH4 plus is from NH3, which is a weak base. HNO3, di ba, NO3 minus is from HNO3, nitric acid, which is a strong acid. So, this solution will be acidic in nature. Kasi malakas to. Okay? Kasi malakas yan. Nado-dominate siya by nyan. SrNO3 2. Oh, ito. SrOH2 tsaka HNO3. Both of them are strong acid and base. So, dapat neutral yung mapoproduce nila. Ito, KNO2. KOH, strong base. HNO2, weak acid. So, we are sure na this solution will be basic in nature. No? NaCN, NaOH, strong base. HCN, weak acid. So, we are sure na yung we are sure that this solution will become basic, no? Basic dapat kasi mas malakas yung NaOH, mas malakas yung base na present. Eto, sige nga, let me try. Calculate the pH of this solution. Sige nga, given everything that I taught you, I'll give you 5 minutes. Kapag may salt, identify if the solution is basic or acidic or neutral, then find the necessary calculation. Sige, go. 5 minutes. Sige, let's see. Wait lang, ha? Shucks, wala dito yung sagot. Teka, sagutan ko lang. Wala ko lang dito yung sagot. Teka lang, ha? Go lang, go. Ah. Okay. Sige, I'll give 3 more minutes. Pang-review na rin to sa huli natin di-discuss, no? Good job. Heart reacts. Sige, I'll wait until everyone gets this item correct. Mo. Sige. Para sa lahat to. Basic or acidic solution? Acidic siya, di ba? Kasi HCl yung isa. So, acidic yung solution. So, dapat yung equation of dissociation mo is NH4 plus H2O equals NH3 plus H3O. Diba? Or kaya, NH4 plus forms NH3 and H plus, no? Yon. Tapos, mag-ice table kayo, tapos equal sa Ka, which is Kw over Kb. Diba? Sige, I'll show you na nga. Ganito guys, ha? Sige, we'll discuss more of this na lang sa ano. Mahaba kasi yung di-discuss natin today. Wait lang guys, ha? This is important. Wait lang, important to, ha? Pingin 2 minutes. Sige, go lang. Answer lang. Sige guys, give me 5 minutes, okay? May nag-message na sa akin na teacher. Sige, go lang. You can continue answering. Importante kasi ito. Okay, game ha. So, plus 10. 307. 307. Okay, sige game. Balik tayo. So, how does this work ulit? Diba, sabi ko nga, yung mga hinart reacts ko, tama kayo. Okay, so paano ulit to? Diba, acidic solution siya. Take note na the H3O from the, the HCl does not react with the water anymore. So, wala tayong pake doon, okay? Wala na tayong pake doon. Okay? So, we just care about yung NH4+. Take note, dahil acidic solution nga siya, yun lang yung magkakaroon na reaction. NH4+, plus H2O, dissociates to form H3O, plus NH4, H2O, H3O+, NH3. Diba? NH3. Okay, sige. Diba yan na siya? What's next? 0.10 minus X ay 0xx, no? Yun na siya. So, by x squared over 0.10 minus x equals to kW over kb. If we solve that, ito makukuha natin. Yan. Tapos, after that, negative log. Tapos na tayo. Negative log H3O. We will get 5.13. Yan. Okay? Oh. Ha?
Anong color? Puro black lang?
Oh, black, tsaka blue.
Red, hindi na red.
Hindi na red. Sige, dalawa lang. Okay na yan.
Dalawang black, isang blue binili ko.
Ay, ganon? Dalawa? Tatlo binili mo?
Ilan ba?
O, tigisa na lang. Red, black, blue. Okay na yan.
Kaso yung
Broad.
yung pinaka-tinta, yung blue, yung malapad.
Okay lang sa akin yun.
Wala ka ba estudyante?
Meron. Sige na, bye-bye. Okay. So, ayun. KW to KW. KW over KB. Using ko yung, sige. Paano kung, ayan, KW over KB yun. Okay? Daming tumatawag sa akin. Hello? Oh.
Bibili ba ako tinta?
Hindi na. Last na yun.
Sige, bye-bye.
Okay. Sorry kainis. Daming tao. Okay. Yan. So, balik tayo kanina, no? Dito, may nagtanong, KW over KB. Kasi, di ba, KA times KB equals KW, di ba? Na, as we remember from our previous lesson. So, to get KA, divide KW by KB. Okay? Sige. Sige, ito, balik tayo. Ayan, I hope that works. Okay. Ngayon, dito naman, what if you're given with a salt, pero weak acid and base yung kasama niya? Example, NH4, ammonium nitrate. NH4, CN. Yan. Example yan. NH4CN. We won't be dealing with this naman. Example lang, ganyan, no? Diba? NH4 plus, tsaka HCN, diba? Yun yung pinanggalingan nila. NH3 tsaka HCN. Pareho sila weak acid and weak base. What you want to do is to compare yung specific KB nito, KA. Okay? Tapos, if KA is less than KB, or KB is greater than KA, basic siya. Kapag KB less than KA, acidic siya, no? So, we won't be dealing with this naman. Pero in case naman naka-encounter kayo, then use the necessary calculations to be able to calculate the pH. Okay, sige. Ngayon, let's discuss na the common ion effect. Ito na, more on titration tayo. More on titration na tayo. So, let's start off with the common ion effect. What is the common ion effect, no? So, the common ion effect occurs when a given ion is added to an equilibrium mixture that already contains that ion, and the position of equilibrium shifts away from forming it. So, what does this mean? Sige, suppose we have acetic acid plus H2O. The dissociation of acetic acid, no? A weak acid siya. Ayan, this is the ice table, di ba? At equilibrium. Let's examine this in equilibrium. Di ba? We would get from our ice table that H3O equals CH3COO minus equals 1.34 times 10 to the negative 3. Where then the pH is 2.87. Okay? pH is negative log of H3O. Okay? Always remember that. Next, ngayon, sabihin natin nagdagdag tayo ng 0.05 molar ng sodium acetate. It's a salt. Remember, it's a salt. Pero, basic salt yan. Bakit? NaOH, di ba? NaOH. So, basic salt. So yung CH3COO-Na dissociates into this. Tapos yung pagkatapos mag-dissociate, mapupunta lahat yan dito. Okay? Let's see. By Le Chatelier's principle, dahil nag-add tayo ng acetate ion, which is this one, equilibrium shifts to the left, di ba? So, papunta doon yung reaction. Alam naman natin yon. So, after everything na mangyari, ganun pa rin, no? The same direction tayo. If we solve our ice table, so bali, ano yung pinagbago? Ito lang. Di ba dati walang, pag nagsisolve tayo ng pH calculation, walang initial dyan sa kanan, di ba? Puro zero lang. Di ba? Ngayon, meron ng initial concentration. So, we resolve this. We solve for x from this one. We get 3.6 times 10 to the negative 5, and we get the pH 4.44. So, ano nangyari? Tumaas yung pH nung nag-add tayo ng CH3COO minus. In short, mas naging basic. Diba? Kasi tumaas yung pH eh. See? Yan. That's the common ion effect, no? Adding ions would shift the equilibrium to the left, thus affecting the pH, no? Then, ba't importante yun, no? Ba't importante to? Kasi, buffer solutions, no? Buffer solutions. What is a buffer solution? This is how buffer solutions work. I can't explain it that well, pero buffer solutions are solutions that contain a weak acid and its conjugate base. And it resists, or a weak base and its conjugate acid that resists changes in pH upon addition of small amounts of either an acid or base. Okay. So yan, example, unbuffered solution. Tapos nagdagdag tayo bigla ng 1 molar HCl. Grabe yung tinaas ng pH, di ba? Nagdagdag tayo ng strong acid. Ang grabe agad yung tinaas ng pH right after. Ay, binaba ng pH, mas naging acidic. Ganon din for NaOH. Grabe yung pinagka-basic ng solution natin. Kaya lang, nung naglagay tayo ng buffer, ayun, di na masyado nag-change yung pH. So, ano yung buffer, no? Ano yung buffer? Example, dito kanina, actually, nilagyan natin ng buffer to. Ito yung buffer, guys. Yung H3COO minus, no? Yung sodium acetate. Yun yung buffer natin kanina. Okay? We'll explain more in a while. So, what happens, no? Never mind this one. So, teka lang. Okay. Sige. Di ba yan? Pag naglagay tayo ng buffer, ito mangyayari. Ito, reacts with the added base. And ito, reacts with the added acid, no? Yung conjugate base natin. So, pag merong ganon, it would balance out yung changes in pH. Let's see what happens. Dito na lang, okay? Yan yung kanina. Yan, see? Tama ako. Calculate the pH of a buffer that contains 0.5 molar acetic acid and 0.5 molar sodium acetate. Ayun. So, yung kanina natin sinolve na example, naging buffer solution na siya. Bakit? Kasi it has the acid, acetic acid, tapos meron din tayo ng sodium acetate. Diba? Yun lang. Okay, sige. How do we calculate the pH of this buffer? No? Yan. So, same thing as kanina, ito lang. Meron tayong initial dito. Okay? Then we solve for x, we get this. Then we get the pH, negative log of that, 4.74. Ngayon, di ba may buffer na tayo? What happens if we add solid strong acid, no, NaOH, to 1 liter of buffer solution? Sige, what happens nga ba? Strong base completely reacts with the weak acid, di ba? So, kung ano may dinagdag natin, di ba, naalala nyo to kanina? Ito na, you'll see how it works, di ba? Yung strong base reacts with the weak acid para maging ganito. Okay? Resolve. Diba? Resolve natin. Then, tsaka tayo mag-ice table. Okay? Yan ha. So, pag nagsusolve tayo mamaya sa titration and yan din sa mga buffer, make sure to react all these solid or all these strong base to your weak acid or your weak base. Okay? Ganon. So, kaya may ganito na yung bagong ice table natin. Solving for x, we get H3O equals 1.7 times 10 to the negative 5 with pH equals to the negative logarithm of H3O plus. Okay? A buffer contains, paano naman pagbaliktad? 0.020 moles of HCl is added to 1 liter of buffer solution. Paano naman pag ganyan yung nangyari? Paano naman pag strong acid yung inad natin? The strong acid completely reacts with the weak base. Diba? With the weak base. Teka lang, ayusin ko na yun, ha? If we see here, ayan, di ba? It reacts completely with the weak base. So, magkakaroon tayo ng initial, tapos magbabawas tayo, di ba? Kasi as long as merong initial amount to, kailangan mo maubos yon, guys. Kailangan nyo maubos yon, okay? Kaya rin ganito dito, di ba? Naglagay muna tayo ng OH, tapos, kailangan natin ubusin yon. Bago tayo mag-ice table ulit. Okay? So, ganito rin dito. Diba? So, acid completes react with the weak base. So, ganun muna. Let the strong acid react with the weak base first. Tapos, do your ice table. After. 0.52 minus x, 0.48 plus x. So, solve for H3O. pH equals negative log H3O, which is 4.7. Kaya lang, may shortcut yan, guys. Given the dissociation reaction of the weak acid HA with the Ka as this one, di ba alam natin ang H3O plus Ka times HA over A minus lang. Kasi, if we take the negative log of H, we get this. And that is the Henderson-Hasselbalch equation. Shortcut siya. Bakit siya shortcut? Kasi pag meron kang conjugate acid, meron kang weak acid, tapos dinagdagan mo ng base, tapos meron kang conjugate base sa solution mo, you can instantly calculate the pH anytime. So, example ito. Balikan natin yung kanina, no? Ito yun, di ba? Strong base reacts completely with the weak acid. Then, makukuha natin yung pH na agad. Yan na. Paano makukuha yung pKa? negative log nito. If you add those, magiging 4.77. Paano naman pag HCl yung dinagdag natin? Ganun pa rin. Pag-reactin mo muna, then use your Henderson-Hasselbalch. pKa plus log 0.48 over 0.52 equals 4.7. Now, this is diagrammically representing paano nag-work yung mga buffer, no? Okay? Ngayon, paano kung dissociation reaction, of a weak acid, di ba? Paano mo pag-base? Paano mo pag-base yung ginagawa natin ito ng buffer, no? Paano pag-base naman yung buffer? Basic yung buffer. Conjugate acid over weak base. Yan, POH naman. Ayun, I hope you can remember these. I hope you can remember these equations, no? Pasensya na if medyo ano yung explanation ko kasi mahirap talaga i-explain to, okay? Ito na yung pinakamahirap na topic ngayon sa grade 10, no? I'm sure. This is the hardest you'll ever encounter. Sige, pakikopya lang to. And ito. Before I continue, kasi tuloy-tuloy na to, ako na magsasalita for the whole time. Gets na ba to? Gets na ba yung mga equation na to? Gets how it works? Okay, so key points. So, paano ulit? Sige, paano ulit gumamit ang Henderson-Hasselbalch? Given na may buffer ka, kumbaga, may acid ka, and its conjugate base, ano gagawin? Pag-reactin mo muna lahat ng mga dinadagdag mong base bago ka mag-ganto. Okay? Pwede rin ito gawin mano-mano, ice table, pero ayaw na natin nun. Okay? Let's use the shortcut. Isa pa. Tapos kapag acid naman, pag-reactin mo muna lahat ng H3O bago ka mag Henderson-Hasselbalch. Kasi we'll be doing all of this, we'll be doing the same thing mamaya sa titration. Okay? Sige. So, okay, gets na. Let's move on. Sabihin nyo na sa akin at any point pag meron kayo hindi gets. Kasi mahaba-haba itong susunod. Okay? Sige. Yan, let's go on to titration. Maganda sana to if you have the experiment, no? Kasi nakaka-trigger siya. Kailangan perfect yung paglagay mo ng substance. Sige, what is titration? An analysis technique, quantitative analysis technique in chemistry used to quantify the concentration of an unknown substance. Take note, unknown substance, ha? Hindi natin alam kung ano yung substance. Tapos ka-quantify natin kung ano siya. Tapos basic terms, sige, kasi we'll be using this all of the time. Titrant, solution added to the substance. Analyte, the substance being analyzed in the experiment. Yung indicator is, or weak organic acid that changes color over a range of pH. I will discuss more later. And point at which the color of the indicator changes. Near the equivalence point most of the time. Equivalence point at which H3O plus equals OH minus in the solution, which is the signal to stop titration. No? Yan, always remember this, no? Equivalence point. End point is near the equivalence point. End point is not equal to equivalence point. Always remember that, ha? We'll discuss more later. Ngayon, before we continue, volume needed to reach end point, no? We need that. M1V1 equals M2V2. I'm sure you've heard of this na last year. I'm sure ginawa nyo na to sa solution chemistry nyo. Ganun lang din dito, no? We're still going to use that. So, important tong equation na to. Okay? So, bale, ito yung titrant. Ito yung titrant, ito yung analyte, no? So, we can estimate, actually, we can see kung saan yung, we can estimate kung ano yung volume na dinadagdag nating titrant to reach the endpoint, no? Okay, so examine yung titrations. Unang-una, examine what kind of titration we are doing. Number 2, determine volume at equivalence point. Number 3, pag nag-ice table tayo, as you'll see later, in millimoles na yung units, hindi na siya molar, okay? Millimoles muna, bago tayo mag-molar. Bakit? You'll see later, no? You'll see later. Sige, first of all, strong base, strong acid titration. The reaction between the strong acid HCl and the strong base NaOH can be represented by this, no? Dahil strong acid sila pareho, ito lang siya basically. H plus plus OH minus forms H2O. Net ionic equation. Yun lang siya. So sige, let's consider the titration of 40 ml of 0.1 molar HCl with 0.1 molar NaOH. Find the pH of the solution after addition of, wala muna, initial pH. Sige, we're going to do that one at a time. Pero before that, this is what you call a titration curve, no? Shows the relation of the titrant added, which is NaOH, to the pH of the solution or your analyte, no? Once na we reach here already, stop na tayo kasi we can determine the concentration of our substance already. Kasi equivalence point is at pH 7, neutral, because the acid and base would have reacted with each other completely. And if you go further, no more point to continue, di ba? So, sige, ano yung mga properties na strong base, strong acid curve? Starts out very low, kasi strong acid nga siya, so very high concentration of H3O+. And increases slowly as the acid is gradually neutralized by the added base. Okay, naalala niyo yung kanina? Strong base plus strong acid, neutral yung lalabas, no? If you've remembered sa last lesson natin. Kaya at equivalence point, pH 7, no? Tapos tandaan nyo, pag malapit na sa equivalence point, yung solution nyo, or yung analyte nyo, steep rise in pH sa titration curve. So sige, consider the titration of 40 ml of 0.1 molar HCl with 0.1 molar NaOH. Una, walang pH na inad, no? It only depends on the initial amount of HCl kasi nga strong base siya, guys, 'di ba? Paano kumuha ng pH na strong acid? Diretso na, negative log H+. Strong acid kasi yan, di ba? pH 1. Oh, half equivalence. Half equivalence is 1/2 the volume needed to reach equivalence point. Okay, by the way, may nilimutan akong gawin. Balik tayo dito. Oh, paano ulit kukunin yung volume at equivalence point? M1V1 equals M2V2. So, if we calculate it, obvious naman, we need 40 ml of NaOH to reach equivalence point. Ang half equivalence point natin is 20 ml. Diba? Okay, sige. Let's go. Let's continue. Half equivalence point, no? So, kita nyo yung ginagawa ko, Puro millimoles lang, puro millimoles. Tapos, after, I get yung concentration again, no? Ang concentration ito is 4 millimole over 40 ml, which is negative log 0.1. Di ba? Yun lang siya. Okay. Sige. Oh. Half equivalence. Oh. Di ba yan muna? Pag-reactin lahat natin ng OH, ito yung matitirang ice table natin. 2 millimoles of H+. Ayan, still depends on H+. Ang concentration ng H+ ngayon ay 2 over 40 plus 20. Kasi yun, dumami yung volume natin, di ba? 2 over 60, if we get that, 1.48. All acid and base react parate, ha? Always remember that. All the acid and base react always. O sige, before equivalence point, 30 ml added. 30 ml added. 3 millimoles expended. So, ang natira na lang ay 1 millimole. Diba? 1 millimole left for H+. Ganun pa rin. Negative log H+. Negative log 1 over 70, 1.85. 1 over 70 kasi 40 plus 30. All acid and base react pa rin. Oh, equivalence point. No acid remains, di ba? Dahil ganyan, neutral pH na yan kasi equivalence point nga eh, 7.0. Mas after equivalence, ano napansin nyo? It only depends on the OH added, guys. OH added na lang yung nagmamatter. So we get the POH, which is negative log OH, 1 over 90. So 1.95. pH equals 12.05. Ayan. Ayan. That's it for this one. Sige, before we move on, I want you to calculate the pH of the pH at pH na solution natin at pH na solution natin at teka, type ko calculate the pH of the solution at tatlo to. 15 ml, 25 ml, tsaka 60 ml. Okay, sige game. Let's go. Try natin if na-gets nyo talaga. Ang ginagawa pa lang natin ngayon is we are examining teka. Okay, before we continue, nag-gets ba? Nag-gets ba, guys? Ito. Okay. Sorry. Teka, let me reiterate this. Okay. Sige, sorry. Calculate the pH of the solution after 15 ml addition of titrant, 25 ml addition of titrant, and 60 ml addition of titrant. Yan. Okay. Yan pala. Sige. Sorry. Pero, okay guys, nagets ba yung tinuro ko sa inyo? Dali, paki-react yung message sa group chat. Gusto ko lang malaman if gets you talaga. Okay, sige. Try nyo I'll give you 3 minutes only. Madali lang yan. Ito lang. Lalagay ko lang dito. Baka lang kailangan nyo ng reference. So, lalagay ko lang dito. Ayan. That's how we do it. Sige, tama yan. Good job. Okay, sige. Ayan. Ingat lang ha. Ingat lang sa pag-resolve nung sige, I'm going to wait for 3 more minutes. I want all of you to get this. Okay? I want all of you to get this. Yan. O sige, go Jeremy. Tuloy mo na. Yan. Nakuha mo na. Sige, go. Tuloy mo yung ibang item. B and C. Sige, I'm waiting for everyone. No? I want all of you to get this correctly before we move on. 3 more minutes. Sige. Yan. Sige, go. Tama yan. Okay. Sige, go. Yan. Okay. Sige, yan. Gets to Jeremy. Good job. Sige. I'll wait. Yes. Sige, go. Continue. Okay, sige, time's up. Marami pa tayong gagawin. Okay, look at the board na lang muna. Oh, game ah. H plus. Ay, mali. Sorry. Ayan, di ba? Oh. 4 millimoles. Di ba sabi ko muna? Ba't pala millimole, no? Kasi number of molars times volume. Ang volume natin in ml, di ba? Kaya millimoles. Para lang madali, no? Sige, millimoles muna. 4 millimoles. OH minus. Dagdag tayo na 15 ml. So, 1.5 millimole. Minus 1.5, 2.5, 0. Negative log, 2.5 millimoles over 55 ml equals to 1.35. Ako, 1.35 nakuha ko eh. Okay, it's okay kung ano may nakuha nyo. Next, 25 ml. Oh, ito lang din. 2.5. Oh, 1.5. Ah, 25 ml added plus 40, 65 ml. So we should get something around 1.64. Okay. Sige, last one. 60 ml added ba? Yes, 60 ml added, sabi ko. Oh. Tama ba sinabi ko? 60 ml added. Oh. 4 millimoles. Ito 6. Siyempre, mauubos to. Ito lang yung matitira. Diba? Yun na yung matitira. So, after that, negative log 2 over 60 plus 40, 100. Negative log, makuha natin dito is 1.70, no? Kaya lang yan ay POH. Remember, kasi OH na yan eh, no? POH yan. So, to get pH, 14 minus POH equals 12.3. Okay? Well, before I continue, nagigets ba? Before I continue. Nagigets ba? Nako naman. Okay. Sige. That's good. Okay, sige game. Next, let's examine strong strong base and weak acid. Strong base, weak acid titration. Or kaya weak acid, strong base titration. No? Parating strong yung, pansin nyo, parating strong acid or base, yung ginagawa natin titrant, di ba? Pansin nyo yun, yes. Kasi pag hindi, mahirap eh. Wait lang. Di ba? Strong parating ina-add natin, no? Yung stronger yung parating ina-add natin. So, sige. Same pa rin, no? Sige. Volume at equivalence point, M1. Volume of NaOH needed to reach equivalence point is M1V1 equals M2V2. No? Solving for that, 40 ml pa rin. Kailangan, naka 40 ml tayo ng NaOH to reach the equivalence point. Sige, game. Oh, ano yung mga napansin natin, no? The initial pH is higher, no? Kumbaga, mas hindi siya ganun, no? Ganito siya. Medyo may curve siya ng konti. Kasi nga, less H3O present than the strong acid. Okay, the curve rises gradually before the equivalence point. Okay, next. Tandaan nyo, ito, ang tawag dito, buffer region. Okay, buffer region to. Ibig sabihin, your solution acts as a buffer dito. Okay? Yun siya. Sige. Tapos, at half equivalence, dito, ano ba to? 25. Dito, sa 12.5, dito, at half equivalence point, pH equals pKa. We will know bakit kung mamaya, no? We will know kung bakit mamaya. Next. Okay, yun na muna. Tandaan nyo, basta pag nakarating na dito, sobrang bagal na mag-rise ng pH, no? Kahit anong acid or base man yun. Sige. Consider the titration of 40 ml propanoic acid, HPR, with 0.1 molar NaOH. If Ka equals this one. Initial pH, 0. It only depends on HPR. Take note, HPR is a weak acid. Diba? Hindi siya strong acid. So, ito dissociate accordingly. Plus X to, no? Plus X. Baguhin ko na nga.
Ayan. Tapos, use ice table. X squared over 0.1 minus x equals to Ka. Tapos, finally, the pH is negative log of H3O, diba? Which is equal to 2.96. At half equivalence, tanda natin, buffer solution yung solution natin, no? Buffer solution siya. Kasi, diba, pag nag-add tayo ng NaOH, magiging ganito siya. So, take note, both, diba, sabi ko, basta may strong acid, papareactin natin lahat. No? Papareactin natin lahat. Katulad na sa ginawa natin kanina. Sige, buffer solution siya, diba? Bakit? Kasi meron ng weak acid and its conjugate base present. So, pH equals pKa plus logarithm of conjugate base over weak acid, which is just 4.89. Ito log 0, no? Ay, log 1. So, 0 siya. So, yun lang siya. Diretso. Straightforward. Before equivalence, same thing. Oh, let all the OH react. So, 1 millimole na lang. Tapos yung PR, magkakaroon din. Ganun pa rin. pKa plus log PR over HPR. pKa, remember, is negative log nito. So, 4.89 plus logarithm of 3 equals 5.37. Yan yung pH niya. And lastly, at equivalence point, remember, no more base remains, no? Rather, no more acid. Mali. No more base remains, no? Wala nang natira sa acid. No? Wait lang. Mali yung nakasulat ito. No more acid remains. Diba? No more acid remains. So, therefore, yung pH, yung PR minus, magre-react siya sa water, no? Magre-react siya sa water. Para maging HPR ulit. Kung magiging, magdi-dissociate siya to form hydroxide and HPR. Okay? Yan. So, solving, we get X equals, kasi take note yung binigay is HPR. No? Kaya lang, pag nakarating sa equivalence point, meron ka nito, magdi-dissociate pa rin yan slightly back to HPR. So, kailangan natin ng KB equals KW over KA equals X squared over 0.05 minus X. X equals 6.20 times 10 to the negative 6. That is POH. Remember, that is POH. Then we get the logarithm of X, 5.2075. pH equals 5.8. No? Then after equivalence point, parang ano na siya guys, parang strong base, strong acid. No? So let's use that model. Kunwari, H plus ito. Tapos kung mapapansin nyo, nothing of the acid remains, only OH. Take note, stronger base OH kaysa sa PR minus. So, ito na yung magdodominate fully. So, concentration, POH is negative log 1 over 90. Take note kasi total concentration, di ba? 1.95, pH equals 12.05. Okay, before I continue, nakuha ba? Nakuha yung analysis. Okay, sige. Ito ulit, may papa-analyze ulit ako sa inyo. I want you to get the pH after addition ng, teka lang sulat ko na lang. Ito pa rin. Teka ito pa rin. Ito pa rin, reply na lang ako. I'll give you 10 to 15 minutes. Or 10 minutes, sige, 10 minutes. Dapat nga mas madali ito eh. Lagay ko lang to dito just in case. 10 minutes. Okay, may comment lang pala ako. Napansin nyo ba kung bakit, tingin lang kayo sa PowerPoint, napansin nyo ba kung bakit ito lang ginagamit ko? Kasi nga, di ba, ang concentration is moles over volume. Pero kung alam naman natin, pareho lang yung volume nila, di ba? So, the volume doesn't matter actually. Ang important lang ay yung moles, no? Kaya kung napansin nyo, minimoles ang ginagamit nating pang-analyze. Sige, go. That's just a comment. So yeah, I want to make sure nagigets nyo to. Kasi yung susunod, I would make you do it entirely on your own. important pala dito guys, gets nyo how to write yung chemical equation. Sige, paano yan? Sige mamaya, after nito, turuan ko kayo. Ito ay sobrang important sa titration, no? Aside from knowing your, ang tawag dito? Aside from knowing your type of titration, you need to determine the volume at equivalence point, tapos get the right reaction per stage of the titration, no? It's really important ngayon. Mamaya, turuan ko kayo. Yan. Yan. Oh guys, yung iba, pag kailangan ng tulong, please tell me. I'm willing to help you. Gusto ko kasi mag-gets nyo to. Kasi I want you to do the next one on your own. Okay? Okay na ba sa inyo yun? Tara, bilisan natin. Kasi alam kong kaya nyo to eh. I want you to do the next one on your own. I'll give you the PowerPoint as early as now para mag-guide kayo sa ginagawa nyo. Okay? Sige. Tara ha. Sige, I'm going to kamusta tayo isa-isa. So, gusto ko yung next one. I want you to do it on your own. Sige, hintayin tayo ng konti. 3 minutes. Oh, ano institution yung ginamit? Ay, sorry. Oh. Sorry, nawala ko yung... Teka ha. Ito, Megan. Wait lang. Ito yung example kanina. See guys, I'll give 2 minutes more.
Oh, sige. Game. Sir, ay pa tuturo sa inyo. Sige, let's start. Okay. Oh. Sige, remember these 3 points. Okay, remember these 3 points. Sabihin ko na sa inyo, ha? Oh. Pag meron tayong weak acid or weak base titration, ito yung mangyayari. Ito yung mga tatlong chemical equation natin. Sa start, diba, only depends dito sa specific example natin, only depends on HPR, diba? So, HPR dissolves into H plus PR minus. Diba? Sa anywhere between HPR plus OH forms PR minus plus H2O. At equivalence point, PR minus reacts with H2O to form H plus HPR. Okay, yun yung tatlong equation parate, no? Pag pag nagsosolve tayo. Tapos after, OH minus lang, no? All the time. Pag acid, baliktad. Okay, pag weak base, strong acid, baliktad na siya. Okay? I'll leave it up to you. Basta yan, pag weak base, strong acid, baliktad siya. Okay? Sige. Ngayon, let's start. Kasi I want you to do the next one on your own. Okay? Sige, game ha. Let's see. Balik na lang tayo dito muna. Ay, sige. Oh. Dito muna tayo sa 15 ml. Ito gagamitin natin, no? Diba, sa start, 4 millimoles. 1.5. 0. 2.5, 1.5 millimoles. So, pH equals pKa plus log conjugate base over weak acid. Pag sinolve natin yan, .66 or 4.67, no? Next, at 25 ml. At 25 ml. Baliktad lang. No? 2.5 o 1.5. Ito 2.5 after. Diba? So, baliktad lang. Equals to 5.11. Lastly, after, 60 ml after. Sige, so OH lang. Sa OH lang yung nag-matter, di ba? Diba? Excess OH. Excess OH equals 2 millimoles, di ba? So to get the POH equals to negative log 2 over 60 plus 40, 100. It's around 1.7. So pH equals 12 minus 1.7. Ay 14 minus 1.7, 12.30. Okay? Nakuha ba yung iba? Nakuha ba before I continue? Nakuha ba? Nakuha ba? Yung iba? Nakuha ba nung iba? Nakuha ba nung iba?
Yung mga hindi pa nakasagot, nakuha ba? Before we continue. Yeah, sige. Okay na. Sige, let's try Game. Game. Let's see Try natin to Game, are you G? Pero sige, let me discuss a bit of the properties. At half equivalence, which is this one. So sige, ano yung properties na strong acid weak base titration? Starts at above 7 malamang, no? Kasi basic nga yung, what are we titrating pala? Ammonia, weak base, with 0.1 molar HCl. Baliktad, di ba? Weak base, strong acid. O, malamang, dito siya mag-start. Kasi, strong base nga siya weak. Basic nga siya noong una. Pero hindi siya ganun kataas kasi weak siya. At half equivalence, which is this one, pH equals to pKa. Okay? Sige. Ngayon, I want you to try this. Itong 5 lang. Sige nga, let's see. Game I'm going to give you 15 minutes. Pag meron kayong di alam, pag di nyo kaya, please, tell me. Okay? Sige, go. Ano yung equations niyan? Sige, let me give you a clue na lang. Ano yung mga equations niyan? Diba, at the start, dahil strong base, weak acid, ito yung mga equations niya. Strong acid, weak base. Sa start, ito. Teka, let's see Yan, yun yung mga chemical equation natin. Okay? Sige. I'll give you 10 to 15 minutes. Yung polyprotic acid titration, next time na yun. Sa problem set discussion na lang yun. Kasi, medyo mahaba yun. Sige, pag kaya pa, ito. Promise, pareho lang yan. Okay, baka nalimutan nyo. Henderson-Hasselbalch for base equals to formulas. Ito yung mga chemical equation natin in case na nalimutan nyo. If meron kayong tanong, please, don't hesitate to ask. If you need hands-on guidance. Sige, next time na natin tapusin yung polyprotic acid. Okay, yes, that's correct. Good job. Okay, paano po ulit malalaman which equation to use? Teka, wait lang ah. Okay, sige. Okay. Sige, may tanong. Okay. So, sa mga pag-solve nyo, what this means, itong sinulat ko sa board, diba, kailangan nyo kasi magsulat ng chemical equation para malaman nyo paano i-solve, diba? So, sa start, as in 0 ml. 0.0 ml. Yan. Ito yung equation. Okay? Sabihin ito, between 0 and the equivalence point. Diba? Ito, at equivalence point na. Okay? Yun lang yun. So, example, sa 20 ml, ito yung chemical equation natin. As to solve for the POH, use this. Henderson-Hasselbalch for base. Good job. Good job. Yun na, gets. Okay. There we go. Hindi, teka mo teka mo. A is correct. B is 9.26. C is ito. Nakuha mo na eh. Ay, hindi pa. Well, you compute. Hindi. Di ba? Sabi ko, at equivalence point, at equivalence point, may ganito, no? Manuel, tama yan. Good job. Tama yan. At equivalence point, may ganito. Di ba? Look at the, may ganito. So, it's based on H3O na. Okay. Megan, ano yan? Ang nakuha mo is POH. Remember, Megan, yung nakuha mo is POH. So, do the necessary calculation. Kasi that's what the Henderson-Hasselbalch says. Diba? POH yung, POH yung equation. Yes, yan. 9.26. Okay, tama yan. Sige, go. I'll wait. I'll give you 5 more minutes kayong lahat. Ayan, tama yan. Okay. For letter B, POH yan. Yan. Tapos ito, sige, for letter A. Point 4. Sige, I'll discuss na lang yung iba. Pero tama na yung iba mo, Jeremy. You're almost there. Double check mo yung concentration mo. Double check mo yung concentration. No? Double check mo yung concentration. Yun na lang yung masasabi ko sa'yo. Nandyan ka na eh. See, 8.78. Yes, good job. Double check mo yung concentration. Nandyan ka na, Mo. You're almost there. Hindi. Total. Diba? Total. Ano ba yung concentration? Total, diba? Ano na yung volume na nandyan? 4 millimoles all over 80 ml na, diba? Mo? Yun. In a sense, oo, pero depende pa rin sa stoichiometric coefficients ng acid or base mo. We're not sure about that. Pero yes, for this, oo, kasi nga, moles H3O equals moles OH. So, in a sense, oo, dapat hati. Oo. Diba? Tama. Tama yung E. Letter D. Okay, remember, letter D, look at the board letter D, di ba? It becomes like this ulit. It becomes like this ulit, di ba? From here, di ba, mauubos na to. Tapos magiging ganito lahat. Kaya lang, yung NH4+, mag-dissociate ulit siya into acid and ammonia. Di ba? Yun. Sige na, time's running out. Sige, let me discuss. Look at the PowerPoint na lang. Vim. Oh, letter A, only depends on ammonia. This is the ice table. Negative log OH. Diba? X squared over 0.1 minus X equals KB. X equals this. Get X from here, solve for X, get 2.87 as the POH. pH is just 14 minus that. Oh, half equivalence. Oh, diba? 2 millimoles added sa H3O. So, yung tira, ito na lang. Kaya lang, if gagawin natin to, take note na POH equals PKB dahil nga half equivalence. Tapos, subtract that from 14, you get 9.26. Before equivalence, so marami rin nakarating sa inyo dito, PKB plus log NH4 plus over NH3. Kasi, buffer nga, di ba? You'd get 5.22 as the POH. pH equals 14 minus 8.78. Okay na siguro yan. That's close, no? Next, hindi siya neutral, guys. Ay, wait. Wrong. Mali pala iyan. Sorry, Mo. It's wrong. Okay, sige. Equivalence point. Diba? Ito na yung sinasabi sa inyo. Na-react mo na lahat ng base mo. So, matitira dito, diba? NH4+. Kaya lang, yung NH4+ na yan, magre-react ulit siya sa tubig. Magiging similar siya sa una nating ginawa. Ay, hindi pala. Sorry. Never mind that, no? Never mind that. Basta magdi-dissociate yung NH4 plus into its constituents. H plus or H3O plus, tsaka NH3. Tandaan nyo, at equivalence point, kung ano man to, kung ano man yung moles nito, magiging, yun yung moles dito, di ba? Yun yung moles niyan. Yun yung moles ng conjugate base niya. Di ba? Kaya lang, it acts as a weak acid niya, di ba? Kasi nga, nagtatitrate tayo with acid. Okay. As yung NH4 plus din, magdi-dissociate siya into H3O and NH3. So, get the initial concentration. 4/80 is 0.05 minus X, 0.05 minus X, tas itong dalawa, plus X. X squared over 0.05 minus X equals Ka, kasi nga acid eh. Diba? X equals 5.27 times 10 to the negative 6. Thus, if we get the logarithm of that, 5.28. Then lastly, after the equivalence point, excess H3O lang. So, negative log, 1/90, 1.95. Good job sa mga nakakuha until doon. Oo nga, tama na pala yan. Hindi ko napansin. Yes. Good job mo. Okay. Sige. Recap. May mga i-upload din ako mamaya, no? Para madali nyo matandaan kung ano yung gagawin. Wait lang, ha? Ayan. Meron akong mga nakitang documents online that can help you remember kung anong gagawin nyo sa titration. Upload ko na mamaya. Sige, volume at equivalence point, M1V1 equals M2V2. Kaya lang, sa problem set natin, we'll know paano pagamitin yan. Kasi minsan, may multiply pa tayo dyan. Next, for strong acids or bases, initial pH is pH of the analyte. Before equivalence point, resolve how much of the analyte is left, then get the pH using Henderson-Hasselbalch. Ay, for strong acids pala to, no? Sorry. Isa pa. Initial pH, pH of analyte, so negative log. Before equivalence point, pag-reactin nyo muna lahat ng mga strong acid and base nyo, then we'll be left with this. Get the pH after. At equivalence point, pH is 7. Kasi nga, strong acid and base, neutral. After equivalence point, it only depends on the excess acid or base. No? Tapos for weak acids, bases, and strong acids, bases, pH of analyte, use ice table. No? Use ice table. Kasi nga, weak acid or weak base yan. For equivalence point, use Henderson-Hasselbalch. Okay. Kapag weak acid yung tinatitrate, pH equals negative log. pH equals pKa plus log conjugate base over weak acid. Tapos pag naman weak base, baliktad. POH equals pKb plus log conjugate acid over weak base. Tapos at equivalence point, pH of analyte reversed. So, 'di ba? Pagdating sa equivalence point, sabi ko kanina, baliktad, 'di ba? Kung ano nasa right side, magdi-dissociate siya back. Use ice table. After equivalence point, it only depends on the excess acid or base. pH indicators, last one for today. Ilang minutes lang ba tayo? Hindi tayo abot sa polyprotic acid eh. Kasi pwede rin mag-titrate ng polyprotic acid. Yung ginawa natin last time, pwede rin titrate yun. Kaya sobrang hirap. Kaya kasi tinuturo kasi siya eh. So sa problem set discussion ko lang ituturo kung paano. Sige, pH indicators. Acid-base indicator sa weak organic acid whose color differs from the color of its conjugate base and whose color change occurs over a specific narrow pH range. Okay, ano may example nito? Yung mga phenolphthalein? I'm sure you know what that is. Yon. It's a pH indicator. Nag-change siya ng color kapag malapit na sa equivalence po. Pag nasa equivalence point approximately na yung pag-titrate natin. So, the equivalence point in the titration can be determined by monitoring the pH over the course of the titration. Kasi pag nalaman mo yung equivalence point, you can relate yung volume added sa volume of analyte present, then you can get the concentration of the concentration of your unknown substance, which is the analyte, diba? So the endpoint of a titration is the point at which of the color indicator changes. And malapit yung color change indicator sa equivalence point na tinatitrate natin. What do I mean? Or look at this. Methyl red for this one. Titration of a weak base with a strong acid. Oh, nagbabago yung kulay ng methyl red at around 4 to 6, 5 pH, pH 5 and above. And kaya ginamit yung indicator para the slightest change, masabi mo nang you've reached your equivalence point. So there's no way to know if you're in the equivalence point unless you have color. Tapos ano naman, HPR with NaOH, ayan, di ba? Phenolphthalein changes at around 8.5 pH, no? Kaya siya ginamit dito. Strong base with weak acid. pH range for some, pero actually, mas important kung saan siya nagbabago ng kulay. Mas importanteng i-take note yan. Ayan, no? Ito, tulad nito, phenolphthalein, gagamitin mo lang yan. Pag alam mo yung pH, pag nag-estimate ka, pag yung pH at equivalence point is around 8.5. Itong methyl red, example, gagamitin mo lang yan pag alam mo the pH of your analyte at equivalence point is around nasa 5.2, 5.3, ganon. Hindi lang porket nasa range. Importante, malapit sa color change. That's how you choose an indicator. As lastly, sige, pahapyaw lang, polyprotic acid. Pwede mo rin siyang i-titrate, no? Sige, last na to. Pwede mo rin siyang titrate. Iba-iba nga ng equivalence point. May tatlo. Depending sa how much protons are there. Kasi nga, di ba, many ionizable protons. Sige, hindi natin ito ma-discuss next time na lang. Pero I'm going to upload the document if gusto nyo pag-aralan, go lang. Kasi ito yung method, no? Tandaan nyo, halos lahat ng polyprotic acid, amphoteric sila, meaning it can act as an acid or base. Kung sa document na na-upload ko. Kasi may mga specific formula. Pero sige, next time na lang, no? Amphoteric, see? Acts as acid, acts as base. Acts as acid, acts as base. Acts as acid, acts as base. Every time na nasa equivalence point, ito siya. Every time na nasa start, ito rin siya. Every time na nasa between ng buffer region, ito siya. Okay? Yun lang. Ito, optional homework. If gusto nyo lang matry, if you want to practice your skills, ito. So, yun lang, guys. That's our last lesson sa program natin. I hope marami kayong natutunan. Sige, see you next week. And bukas, sorry pala, see you bukas. Problem set discussion on waves and acoustics sa physics. Okay, sige guys, yun lang. Maraming salamat. Bye-bye. Sige. Sorry sa maraming disturbance kanina, no? Marami lang talagang kumausap sa akin. Sige.